So this is going to be our conclusions for our graphing motion lab. And being as such that most of you did not do the lab correctly because you didn't follow the instructions as they were written, it is very important that you pay attention to the conclusions here so that you understand and you comprehend what these graphs are showing you and how to make interpretations from the graphs and their shapes. So first of all, here's what you had. You started off at 0 and you started walking, and every 2 seconds you would make a mark. You made a mark of some displacement, how far you were from where you were starting. The first 8 seconds might have looked something like that. Just kind of a random walk, make a mark. But then specifically, it said that at 8 seconds, the walker should speed up their pace and walk faster, which means you're going to cover more distance quicker. And your graph should have looked something like that over those next 8, 10, 12, and 14-second marks. You covered more distance. The displacement here was greater for the same amount of time. So my graph is steeper. Well, once you got to 14 seconds, it said, stop walking. Stop walking. And this is where you guys fell down on the lab procedure. You didn't read this. You stop walking, but you continue making marks until you get to 20 seconds. Obviously, those marks have the same displacement. They're the same distance because you're not going anywhere. Your graph has a little flat top to that. And then you turned around and you started going back the other direction, which means your displacement is now actually decreasing because you are getting closer to where you started from. And it said on the instructions to walk at a quicker pace. You should have been walking so fast that you went past where you started, something like this, for 12 seconds or 6 drops. We're at 32 seconds here. You should have something like this. And then it said to slow down and walk painfully slow until you got to 40 seconds. And you were well past where you started from, but now the time is up. So now the question is, what do these graphs tell us? And I need you to think about what you were physically doing. For example, what does a steeper graph represent physically? Well, here the graph is steeper. That's where I told you to pick up the speed, to move faster. And you'll notice that the graph is steeper because the slope of a displacement time graph or a distance time graph tells you the velocity. The slope of that line is bigger, meaning you were moving faster. You had a greater velocity. And that's exactly what I told you at 8 seconds to pick up the pace. Also, in this section here, notice the line is pretty steep. You were told to move rather quickly. So the line should be fairly steep. It should have a pretty high slope, which means you're going faster. But you'll notice now the slope is going downhill because now you're moving in the negative direction. You're going back towards where you started. So the slope of that line is negative because your velocity is negative. You're moving back to where you started from. So what does a flat graph represent? Well, what was going on right here? You were just standing there making marks on the sidewalk or on the floor, and you weren't moving anywhere. So a flat graph represents no velocity. Now, if we think about the slope of a distance time graph indicates velocity, a horizontal line has a slope that equals 0, so 0 velocity. Now, how can you tell where there was an acceleration based on the shape of the graph? Remember that acceleration is a change in velocity. Well, where did the slope change? Right here, we had an acceleration because the slope of the graph changed. Velocity increased. But technically there we had an acceleration because my velocity went to 0. Here we had an acceleration because my velocity changed. Here we had an acceleration because my velocity changed, because an acceleration is any change in velocity, and those are the points where the velocity changed. And I want you to think about, what did you do right here? I said, go faster. And by going faster, you changed your velocity. So right at that point, the velocity went from being this line to being that line. Has a greater slope, which means it has a higher speed. So at this point, I hope you have some kind of understanding of what these graphs show you. I want you to take the quizzes that is posted in the daily agenda to see if you understand these or not, because these will be on the test next week. Now, it's set up so you can see the answers at the end of the activity, and I'll put a done stamp in your notebook on Monday if you complete this quizzes before the deadline, which is Monday morning.